Okay, now we shall do this volume of revolution about the y-axis. Okay, just now we have done this. The volume rotate about the x-axis is this one, y square dx. Okay, rotate about the x-axis. Okay, so now we are going to do rotate about the y-axis. So let's say I rotate about the y-axis, the same curve, I will get something like this. That means this will be the circle, this will be a smaller circle, and all these electrons will rotate. Okay, 360 degree. Okay, so you see we have so many of these. So everyone, you look at this one, the radius is xy, because for this electron the coordinate is xy. So that means this is x, isn't it? Y is here. Y is not the radius is x. Xy, this is x, this is y. So the radius is x, so the area will be pi x square dy. And then again, like just now I said, we have so many of these, then volume of the solid, the whole solid, we have to add one by one. Therefore you add, this is the answer. Integrate means we add one by one like that, and then it's from 1 to 4. Okay, so you see, this is the formula. So you remember, when rotate about the y-axis, then this is dy. Okay, when you rotate about y-axis, this is dy. Okay, so when you rotate about the x-axis, then this is dx, pi y square dx. Rotate about y-axis, pi x square dy. That is how you memorize. Okay, then you see for area. So for area, again, this point is xy, this point is xy, that means this is the x, and then this is the dy. So you want to find the area, so it's x dy again, and then 1 to 4. You see, the formula is almost the same. Okay, that is how you find the volume. Okay, now you look at this one. Okay, let's say I have these two curve. One is the red one, and then the other one is a blue one. Okay, that means we have so many electrons here. The blue electron is here, and then the red one is here. We have so many of them. Okay, billions of them, which I can't draw one by one. And then you see the red one will rotate. When the y-axis rotate, the blue one also rotate. So you will get something like this. The solid form is something like this. So if you cannot imagine, now I show you a smaller size, of course. So you see the red one will rotate like this. They form just like a bowl like that. Okay, and then inside this, or just like a watermelon, this is half of the watermelon. And then what we do here, in the middle here, we remove this one. We remove this. We take away this. So this one we remove. We take away. We remove. That's why we get the shape like this. So it's a half watermelon. Then we remove this one from the watermelon. So the remainder will be this. So now you look at this one. For this point is x, y. So because you rotate here, x is the radius. So let's say x2. And then here also x and y. Let's say x1. The radius will be x1. Okay, so the volume here will be pi x2 square dy, because you rotate at the y-axis, dy. Okay, here also you rotate y-axis, so dy by x1. So this one minus this one, x1 square. So when you combine, you will get this. So this will be the formula. Okay, this one is when you rotate about the which axis? The x-axis. The y-axis, isn't it? Here we rotate about the y-axis. Just now that one, we rotate about the x-axis. So you have dx. y1 square minus y2 square dx. So when you rotate about the y-axis, it's x2 square minus x1 square dy. Okay. So you see, when I want to find the area of this region, so I want to find this area. Then this one will be x2. So the length will be x2 minus x1, and then the thickness will be, or the height will be dy. So you see the formula is almost the same. Okay, so that is how, what is the difference between rotate about the x-axis and y-axis. So here you remember, here I give you, when the y-axis rotate about the y-axis, this will be the formula. You remember y-axis, dy. When the x-axis rotate, dx. Okay, so you remember this. Okay, so now we look at this question. Example, I show you the example here. Okay, you look at this one. Okay, the question I've already posted. Okay, look at this one. Question number 1. Calculate the volume of the solid of revolution form when the region bounded by the curve and the line below is rotated through 360 degrees about the x-axis. Be careful, x-axis. So I'm going to show you this B. Y square equal to 6x and the line y equal to. So of course we need to sketch this line, this curve and this straight line. And then remember is x-axis. So if x-axis, this formula we are going to use. We are going to use this formula, not this formula, because x-axis. So now I'm going to sketch the curve. That is y square equal to 6x and the line y, this is a straight line. Okay, so you see how I sketch. Okay, y square equal to 6x, so y equal to plus minus square root of 6x. So I told you already, when you want to sketch this graph, last time, first semester, I give you the 5 tables. This is one of them. So I say you just choose minimum 3 points. So you can choose more. You can choose 5 points or 6 points, up to you. But here I choose only 3 points. Then after that, I can sketch. There you see the blue color. Then this is y square equal to 6x. And then this is a straight line passing through the origin. So this is y equal to 2x. So now what we want to find is now the region. Okay, the solid form when the region bounded by the curve and the line rotate. The region bounded by the curve and the line. This is the region. And then this one rotate about the x-axis. So this formula we are going to use. Okay, so that means like this. Y rotate about the x-axis. This will be the radius. This will be, when you rotate, the radius is like this, right? This is the radius is like this. So this is the radius. So how to get? Is y1 square minus y2 square dx. So I just substitute. You see, rotate about the x-axis. This formula I'm going to use. So y1 square minus y2 square dx pi. Okay, then you need to find the limits of integration. So this is 0, and then this one you can find by solving the simultaneous equation. Then you get x equal to 3 over 2. Okay, then after that you just put in here 0 to 3 upon 2. Then after that you just bring in, substitute in your y1 square, because your y1 square is 6x, and then the y2 square you just square it. So you have this, and then after that you integrate, you substitute, then you get this answer. So that is how you find the volume. Okay, now I give you another one example. That is question number 2. Find the volume of the solid of revolution form when the region bounded by the curve and the given line is revolved through 2 pi radian. Is the same, 2 pi radian, but now it's the y-axis, not x-axis. Okay, I give you B again. So y equal to ln x, the x-axis, the y-axis, and the y equal to 3. So the region is bounded by 4 lines, 1 curve and 4 straight lines, 3 straight lines. So the curve is y equal to ln x, the x-axis, y-axis, and y equal to 3. So I show you where is the region. So you want to draw this line. So this line, last time I give you, you put negative infinity, 0 infinity, you get this one. Then you can draw the line. This is 1. And then the x-axis, this will be the x-axis, bounded by the x-axis, the curve is here. And then the y-axis is here. And then y equal to 3 is here. That means this region. And then rotate about the y-axis. So rotate about the y-axis. Then this formula we are going to use. We have to use this formula, not this. So this is the formula. Rotate about the y-axis. So now when you rotate about the y-axis, So this will be the formula dy. And then what you have to do here, you must find what is your x2. So is x2 is this one, the one outside. Then the x1 is 0. So the x2 will be e to the power y, and then x2 square will e to the power y square. Then you substitute. Here you substitute pi, and then from 0 to 3, the y, the value of y is from 0 to 3, and then x2 square, this one, minus x1 square is 0, so this one. Then after that you integrate. Remember how to integrate exponential. The bracket is here, you must have a 2 here, divided by 2, and then here you get, this is the answer. Okay, let's say you want to find the area. Let's say, just for you to compare, I want to tell you the formula here and the formula here, they are almost the same. So when you want to find the area here, so it's x, you see, this is x2, x1. But here you want to find the area, you don't square it. You don't square it, just x2 minus x1. So the x2 is ey, and then same limit from 0 to 3. So you don't square it, so that is the answer. Okay, but volume you have to square it and with the pi. Okay, so that's how we do number 2. And then I give it another one. That is question number, you see, question number 4. You are asked to sketch, you see, sketch the line y equal to 4 and the curve, this is a parabola and this is the hyperbola, y equal to 1 in the same diagram. So I'm going to sketch. So I show you how I sketch here. You see, parabola. Okay, y equal to 4 is this straight line. This is y equal to 4. That means this y equal to 4 is this line, this straight line. And then parabola, the blue color, and y equal to 1 over x, the red color, this one. Okay, and then calculate the volume of the solid generated when the area bounded by the line and the curve in the first quadrant. That's why they want only the first quadrant here. Bounded by the line y equal to 4, the parabola and the hyperbola. So it's this part. There you see, bounded by the line, the parabola and the hyperbola. So it's this part. Right now. So in the first quadrant. And this is revolve completely about the y-axis. So when you want to rotate about the y-axis, you have to use the formula for rotating about the y-axis. This is the one. Okay, so this is the one. So now you see, so rotate about the y-axis. So this is the one. Rotate about y-axis, dy, so x. So that means, you see, this will be the radius. Now this is the radius. Because you rotate, the circle is like this. The y-axis rotate like that. That means this will be the radius. Correct? So this is the radius. So it's x2 square minus x1 square. So what is the x2? Because here you see, this one is blue color, y equal to 8x2 square. So your x2 square will be 1 over 8y. And then here, y is your x1 square, because your x1 is this one. So x1 square, you square it. Okay, so for volume, you have to square it, the x1, x2. Then after that, you substitute. After you substitute, then you see that this is y, negative 2, and so on. This one, integration, you know how to integrate. Okay, we have learned already. And then how do I get this one is 2? How do I know this one is 2? I solve simultaneous equation so that I can find the limit of integration. So how do I get the 2 here? I solve simultaneous equation. Then I get y equal to 2. I get x equal to half and the y is 2. But x is not important. The important is the 2 because I want to get the limits of integration. Okay, then you integrate. After that, you get this answer. Okay, so this is the answer. Okay, so now I show you, if let's say I want to find the area. So you want to find the area, is like that. You can cut it like this. Okay, so it's x2 minus x1. So you say area, we don't square it. We just take as x2 and x1. Then the area x2 minus x1 dy, and then 2 to 4. Then after that, you integrate. Then this is the one you can simplify it yourself because I have no space here. Okay, that is how you do number 4. Okay, After I give you one more example, and then tomorrow I will continue. But you can start doing if you have time.